Here's problem 621. A sample of blood is placed into a centrifuge of radius 15 centimeters. The mass of a red corpuscle is 3 times 10 to the minus 6 kilograms, and the centripetal force required to make it settle out of the plasma is 4 times 10 to the minus 11 newtons. How many revolutions per second should the centrifuge be operated? Well, let's take a look at this based on what we know. And if we're going through a centrifuge with a wall, and this red corpuscle is sitting against the wall, there will be a centripetal force on it that's helping it maintain its circle, the radius of this circle as it's going around. And so the mass times the velocity squared over the radius will be equal to that centripetal force. Well, the velocity that we're talking about then is equal to the centripetal force times the radius divided by the mass square root. In this case, that's going to be equal to 4 times 10 to the minus 11 newtons times the radius, which is 0.15 meters, over the mass of the red corpuscle, 3 times 10 to the minus 16 kilograms, all that square root. And that's equal to 141.4 meters per second. That's how fast the red corpuscle is going in a forward direction along the circumference of this circle. Well, if it goes a full circumference, 2 pi r, then it will do a revolution. So our revolutions, our frequency of revolutions in revolutions per second would be equal to this velocity divided by the full circumference of the circle, this velocity divided by 2 pi r. And that will be how many revolutions per second we're doing. And that's going to be 141.4 meters per second over 2 pi times the radius, 0.15 meters per revolution. So the meters cancel out, and this will give us revolutions per second. That is 150.0 revolutions per second. So that's how fast this centrifuge is going, 150 revolutions per second.